In 2019, the British government committed the UK to achieving net zero greenhouse gas emissions by 2050. Over 130 countries around the world have pledged to hit the same target. It's a highly ambitious deadline, and it needs to be. Delaying action on emissions risks runaway climate change. At the same time, choices we make now will live with us for decades or centuries to come. It is important we act now, and it is important we get this right. This series of video explainers will explore how we navigate our way through an increasingly complex and connected modern world to reach net zero, in line with the Paris Agreement. We call this joined-up process a system transition, and it's how we get to net zero. Nicholas Stern is a former chief economist of the World Bank, who hit the headlines in 2006 when his Stern Review on the Economics of Climate Change was published. The 700-page report laid out in stark terms the devastating economic toll that climate change would have on the global economy if left unchecked, and stressed the economic benefits of early intervention. 15 years later, net zero remains at the top of Stern's agenda.
If we're going to stop temperatures rising, we've got to go to net zero. And to get to net zero emissions, we have to radically change in real time, just 2 or 3 decades, the way we run our economies, and that first decade will be absolutely decisive. But when we look at that challenge, actually we will be discovering and creating a new form of economic development, much cleaner, much healthier, much safer, and much more productive than has gone before.
But government setting an audacious goal is one thing. Making it a reality is a far bigger challenge.
We have really the biggest transformation the world has probably seen in a peacetime economy, with enormous progress required this decade. But you've got to invest to get there, you've got to change quickly, you've got to manage that change, changing in the very big systems of cities, energy, transport, land, and of course a big change in the overall system of the way the economy functions.
Achieving net zero is a massive systems challenge. It's going to involve simultaneous transformation of a whole range of vital and interconnected infrastructure systems, from transport and housing to energy and manufacturing. So we absolutely have to take a systems view to understand interdependencies between those different components of a system, understand where the trade-offs are that we're going to have to make, opportunities for leverage and incentivising the right behaviours so that we can align all these different factors towards this singular outcome of net zero.
A systems perspective shows us the crucial connections between the systems upon which we depend. Infrastructure systems around the globe rely on natural resources and ecosystems for their materials, energy, and safe operating conditions. In turn, our infrastructure systems depend on and support each other, so when we make a change to decarbonise our transport system, it also changes what we need from our energy system and from our built environment, and vice versa. Making good decisions for any of these, and especially making decisions that protect the ecosystems they rely on, requires a strategy for all of them.
Without a framework for joined-up policymaking, finite resources such as zero-carbon electricity supply or the rare metals that we need for key technologies such as batteries are not going to be available when and where we need them. So we end up in a position where we could be in this macabre version of whack-a-mole, where we reduce emissions in one place and then they pop up somewhere else in the economy or perhaps in another country. We deploy new technology but we don't have the right structures in place to get the benefit. You can end up creating more problems than you solve.
Engineers are often the people building, operating, and integrating all the parts of these different systems: transport, energy, and buildings. Engineering skills and systems thinking are needed to bring them together to create a net zero future that works.
Engineers are innovators, problem solvers, systems thinkers. They're fundamental to fully realising net zero anywhere in the world. And the systems approach is really core to engineering. It's what we sometimes call one of the engineering habits of mind. And it provides us with this structured, disciplined approach to managing complexity. It's like a toolkit that we can use. Engineers can also use systems approaches to handle less tangible products and to help us cope better with uncertainty. So it's really important to remember that when we talk about systems, we mean socio-technical systems. We need to think about how systems work in the real world, interacting with people and planet.
Implementing net zero is an unprecedented and all-encompassing challenge of delivery and integration. Engineers will need to collaborate with other disciplines, policymakers, and crucially the public to guide the transition in a sustainable and just way for all.
It's a combination of science, engineering, public policy, city planning, town and country planning. It all has to be put together. So you need the systems engineers of the really technical system engineering kind, because these are complicated engineering systems. But at the same time, you need the systemic side of society, economy, government to make this happen. And the government side is critical.
With the world's attention currently fixed on COP26 and what comes next, this series of video explainers will explore what a system transition is and why we need to make it happen. By looking in turn at energy, transport, the built environment, and how they all come together, we hope to inspire those making the key decisions in government, industry, and beyond to harness a whole system transition to net zero, guided by justice and enabled by engineering. Our built environment is everything that humans have constructed around us. It's the framework in which we live, work, and play. It is the environment created from weaving together our homes, schools, hospitals, offices, historical landmarks, and city parks. And within the built environment runs the infrastructure that moves power, water, food, and people to where they need to be. The built environment is massive, and it's getting bigger. Unsurprisingly, that comes with a considerable environmental impact. Welcome to episode 2 of Getting to Net Zero, a series of explainers from the National Engineering Policy Centre that we hope will help you to harness a whole system transition to net zero, guided by justice and enabled by engineering. In this episode, we're finding out how there are no silver bullet solutions to making our built environment compatible with a safe climate. Instead, as we'll see in this video, we need to approach the built environment not just as a collection of individual buildings that require individual solutions, but as a whole system, where each smaller solution is part of a transition. Our built environment is large and complex, and so are the ways it contributes to climate change.
Emissions are created in the built environment in a number of different ways. I suppose the first and most immediate one we think of is the emissions in use of a building. So those, such as heating or cooking. But there's also the emissions that are created in the construction of the built environment. And also the embodied carbon within the materials which we use to build the buildings. But perhaps we also need to consider the landscape and the environment, because in creating these buildings, we disturb the natural environment, and therefore we reduce the opportunity for carbon capture within the landscape.
Transforming the built environment will be a crucial part of any nation's response to climate change. But it may also be one of the hardest and most rewarding engineering challenges of the transition to net zero.
In order to tackle emissions, we need to take a systems approach overall. And the reason for doing this is that we get a really clear understanding of the interactions between different systems, so buildings and transport and energy. And we understand what are the right policy levers or what are the right actions we need to take to decarbonise the whole system. If we do not take a systems approach, we are likely to implement changes in a particular area which may lead to unintended consequences.
With such a complicated task and the clock ticking to reach net zero, it's best to start with the basic building blocks. How can we decarbonise the materials and tools that we use to construct and change the built environment?
Probably two things make it very challenging. The first of those is we need to electrify plant, and the plant that's involved in civil engineering is very large. So you're looking at big cranes, pile drivers, things that are difficult to electrify because they require a high power output. So that's one issue. is about how do we electrify the plant that is involved in construction. But probably the biggest issue is that there is a very large amount of carbon that is embodied in the materials that we use in modern construction.
To understand why it's so hard to eliminate carbon from the built environment, we can look at the material that produces more greenhouse gases than any other.
Concrete is a ubiquitous material in construction because it's strong and because you can set it into any shape. And for some pieces of infrastructure at the moment, it's largely the only affordable option, I would say. Concrete is the most widely used material on Earth after water, which I think is the most amazing fact. And it is responsible between 5 and 7% of global carbon emissions, depending on whose database you're looking at, but something around that. So it's responsible for a large amount of carbon emissions.
Concrete's strength, versatility and low cost have made it the go-to material for construction projects all over the world, including for projects like low-cost housing that are key to raising global living standards. So we need to find a way to make net zero concrete. And that's no simple task. Concrete is made by heating limestone and clay to 1400 degrees Celsius. This leads to a chemical reaction that produces a material called clinker, which is what gives concrete its strength. But this reaction directly produces carbon dioxide. To decarbonise concrete production, first we need to tackle the mining process, as well as the transport and processing of materials. They could be decarbonised with zero-emission machinery and electrified transport, and the high temperatures needed to initiate the chemical reaction could be powered by hydrogen, if it's generated in a low-carbon way. But half of concrete's CO2 emissions are caused by the reaction itself, so those gases would need to be physically captured and stored. Not an easy thing to do. Decarbonising concrete involves a lot of steps, needing new resources, designs and machinery. Ultimately, it even requires zero-carbon energy and transport systems. So in the meantime, can we replace this basic building material? There are a lot of potential alternative materials, although each comes with some environmental cost. Cross-laminated timber is strong and potentially carbon neutral, but sources materials from trees, with the accompanying ecosystem impact. This is one of the many new building materials which will be part of the solution, but many more need innovation and testing at large scale to compete with cheap and available concrete. So while we invest in and learn how to use new materials, how can we make construction less damaging to the climate? One way is to reduce demand for concrete by simply reusing buildings instead of demolishing them. In Oxford, a major engineering project is underway to give an old listed building a new lease of life.
Wolfson College has always seen itself as quite a modern college. We were founded in the 60s and our building was built in the early 70s. But the fabric of the estate around us is starting to show its age. And when the building was built, it was before the oil price shocks of the early 70s, so nobody really thought about the emissions. We are probably one of the worst emitters among the Oxford colleges, and it's become very clear to us that the defining question for running an organisation like ours is how do you reduce your emissions?
The retrofit is part of an ambitious goal for the college to become net zero by 2030, with a 75% reduction in emissions by spring 2022.
The aim of our work here is to decarbonise the Wolfson estates. It's mainly a big complex of buildings all built at once in the early 1970s. And like many buildings of that age, their energy demand is dominated by space heating. The structure is concrete, but most of the walls are made of windows and they leak a lot of heat. So in trying to decarbonise the buildings, we're trying to massively reduce the heat loss.
The first step is to replace the building's original single glazed windows with new ultra-thin triple glazing. That move alone will lead to an 80% reduction in the building's annual space heating requirement. To reduce the estate's carbon footprint further, its old gas boilers will be replaced by modern air source heat pumps.
Heat pumps historically are very efficient at making heat at a low temperature, which is good for new buildings, but for old buildings it's very difficult to keep them warm. So here we are using a different sort of heat pump technology with carbon dioxide as a refrigerant, which has different characteristics. This building is a great test case for how to decarbonise buildings of this era. They all have similar problems, and so solutions that work here will be applicable to other buildings.
What you can take away from what's happening here is that it is possible to do. It takes commitment, it takes time, it takes disruption, but all those things are pretty small in comparison with the result that you can achieve at the end of it. So it's that message of hope, not despair, about the challenges we all face in the 21st century with climate change. You need leaderships who are committed, you need people who are living and working in these organisations to be able to live with the works and the disruption. You need the government to create the framework and the financial framework, and you need the engineers and the technicians who can, in convincing and clear words and diagrams, explain to policymakers that this is a good policy choice.
Elsewhere in the world, engineers are looking at ways of reusing concrete from demolished buildings to build the next generation of homes and infrastructure. Dr. Boksun Kim is a structural engineer and head of a project developing and advocating for wider use of recycled concrete aggregate, especially in regions where construction is happening fast.
50% of the world population lives in towns and cities, and this figure is expected to increase to 68% by 2050. And due to the increase of population and fast urbanization, in particular in Southeast Asia, cities need to provide more infrastructure, buildings and houses. However, as the space is limited, low-rise buildings are demolished and high-rise buildings are built in the same location. So this causes a problem, since the construction waste from the demolition is currently regarded as industrial waste and unused.
It's a huge missed opportunity.
Generally, people believe that recycled aggregates give low strength and quality. Yes, quality control can be problematic, and also recycle companies require big investment in large infrastructure and processing machines. So currently, it's easy to dump things than recycle them. However, research has shown that quality can be controlled, and we can develop a target strength concrete using recycled aggregate. Policymakers should consider to promote the use of more recycled aggregates in construction.
There's no single solution for making the built environment net zero. But as we've seen, there are many solutions. Looking at all of these together in a systems approach offers a roadmap to a more climate resilient and better world than any one big solution could do. We've looked at a lot of these already. Where embodied carbon is trapped inside buildings, we do everything to reuse them instead of rebuilding them. Where the materials are a problem, we systematically seek and test and innovate alternatives. When we have to use concrete for a new building, we recover it from waste rather than extracting and making more. Combining all the smaller targeted solutions in just the right way could be a recipe for transformational change, allowing net zero processes and industries to flourish. This approach can make it much easier for communities to tackle the complexity of net zero by developing transition plans to shape their local environment over decades into a sustainable, prosperous and healthy one.
Decarbonising the built environment is a daunting task, an enormous challenge, but equally we should see this as a fantastic opportunity to transform our sector. It will enable us to be greener, to have much more efficient systems, to utilise technology and to create jobs. So I remain optimistic that if we can accept this challenge and face into the rapid transformation that is required, we will achieve these objectives by 2050.
Join us in the next episode, Energy, to continue our series of video explainers on how to deal with climate change by harnessing a whole system transition to net zero, guided by justice and enabled by engineering. Since the industrial age, fossil fuels have dominated energy supply and consumption in most parts of the world. The energy derived from coal, oil, and natural gas has powered our everyday lives, driven industrialisation on a massive scale, and transported goods and people around the globe. It's been the fuel around which we have designed our vital infrastructure, and our technology evolved to rely on it. Dismantling our reliance on fossil fuels will be no easy task, but it's one we must complete with urgency. Emissions from burning fossil fuels are responsible for 3/4 of the global greenhouse gas emissions in any year. And if all the known fossil fuel reserves were burnt for fuel, the CO2 emitted would be 3 times more than the remaining carbon budget, which is the maximum amount of CO2 we can emit and stay within even 2 degrees of warming. So meeting any of our climate targets means we have to end our dependency on fossil fuels for energy.
We're starting from a base that's already had, a century's worth of investment, and we're at that cusp now of having to redesign, reinvest, and recreate a whole new energy infrastructure. In many ways, this is the 21st century challenge that needs to be addressed, and in so doing, we can have the excitement of reimagining a low-carbon energy infrastructure fit for the public's use, fit for industry and business use, and fit for decarbonising our economy.
In this episode of Getting to Net Zero, we will explore the transition to sustainable energy from a systems perspective. We'll look at the global picture to understand the challenge ahead, the policy priorities for high-consumption nations, and meet the people creating new ways forwards on the ground. The energy system is everything required to power our manufacturing, transportation, our buildings, and most of our activities. Energy must be generated or extracted from natural resources. It must then be made available at its point of use. Different end uses require energy in different forms. Most of our energy still comes from non-renewable sources such as coal, oil, and gas. The rest is produced from either renewable sources like the sun and the movement of water, wind, and tides, or from nuclear energy. Between generation and consumption, there is a complex industrial sector for converting between different fuels. This is required to store energy or convert it to a form that is usable across the range of things we need energy for. Globally, this adds up to a highly complex infrastructure network of generation, supply, and use. But this is a global picture. There are many different kinds of energy system around the world. The way that energy is generated, distributed, and consumed is shaped by environmental, economic, and social needs, natural resources, and existing infrastructure. But there is a vast disparity between the amount of energy used by the world's most intensive consumers and those with little access to it. The highest emitting 1% of humanity have an average carbon footprint 75 times larger than the average footprint of the lowest emitting half of the global population. That means that transitioning to a sustainable energy system will look different from place to place. But when it comes to high consumption societies, there are some common principles for finding and prioritising solutions. The first priority is demand reduction, curbing excessive energy demand through combined economic, infrastructure and lifestyle change.
Very often we concentrate our efforts around the supply side, and that's understandable because of the ageing infrastructure that we need to replace and the scale of investment that's required. But the demand side of the equation is also critically important. If we can control and manage demand, then of course the supply side is not so stressed.
There are choices people can make to reduce their consumption, in particular transport choices. But demand reduction has to be built into government policies, like supporting innovation and adoption of low-energy products and processes for both industry and consumers, preventing large-scale energy waste by reviewing economic incentives, and even reducing how far people need to regularly travel through town planning. When it isn't possible to reduce demand, we need to make sure the energy we do use is used efficiently and not wasted. This is often technological efficiencies like car and jet engines, which use less fuel, or insulating buildings so that less energy is used to heat and cool them. Minimising demand and maximising efficiency would make it much easier to then provide all the energy we need from only zero-carbon sources. But our demand for energy is still growing, and growing faster than zero-carbon generation is, meaning that our demand for fossil fuels is still going up each year. In Wales, A team of designers and engineers have created a prototype building that hopes to help reduce that gap between supply and demand. Their active buildings are capable of generating, storing, and even controlling use of their own energy.
The difference between an active building and a building that just has, say, solar energy technologies on the roofs or walls is the fact that we've also got energy storage and smart controls. So that enables us to control when energy is imported to the building and when energy is exported from the building. Potential benefits of this active building approach is that each building becomes its own energy system, which can then be connected up to lots of other energy systems or buildings, so that instead of just having a centralised source of energy, we've got all these smaller decentralised sources which are all able to work together and choose the right source of energy to use at the right time.
This decentralised approach can also change people's relationship with energy.
Currently, we all just take energy for granted, so we don't necessarily relate our own individual houses to the bigger picture. With active buildings, the building user or building owner becomes really an energy prosumer, so we're producing energy as well as consuming it. And I think what that does is connects people to their energy. People are more aware of where their energy is coming from.
While this prototype uses solar energy, that's not the only way of doing it. In fact, a lot of time is spent debating which kind of zero-carbon energy we should focus on. But the reality is that meeting our demand with zero-carbon energy will need all of them, and a lot of energy storage. No single technology will do everything, and each is suited to different places and different energy systems. The key is designing a sustainable energy system that meets local needs.
Many of the energy infrastructures that we see in society today are based on a hierarchical model of large centralised stations. We have to now think about new architectures. We have much more broadly distributed energy sources. So in many ways we now have to invert the challenge again. So being constrained by the conventional architectures will limit our opportunity to reach that low carbon future. So this is where engineering and technology and innovation and design of a new low carbon energy system will be critically important.
This decentralised approach is being made into a reality in rural India, where the Green Switch project, run by Tata Capital, is building energy systems for isolated communities.
What we aim to do from the project is to provide a long-term solution which would probably transcend our own lifetimes, right? And that is what we are trying to do here, future-proof a particular problem for these communities. So instead of switching them first to a conventional thermal source and then probably, reintroducing a new technology, we thought it would be better to introduce a clean form of technology which is affordable for these communities directly.
The communities provide the land, install the microgrid infrastructure provided by the project partners, and receive training to maintain the system.
Key to the entire thing is the community. Because this the model that we are trying to build is a community ownership model, the community plays a key part because they will finally own the microgrid.
The communities involved have seen many benefits. One of the big changes is that families no longer rely on kerosene for heating and lighting. Kerosene creates serious air quality and health problems when burnt indoors.
We've seen that we've eliminated this particular source. Therefore, we've reduced other health impacts to especially women and children, which would be irritation to eyes, respiratory problems, etc. Plus, we've reduced the amount that they have had to spend on kerosene or the time that they had to travel to buy the source itself. Besides this, we've also seen that women and girls especially have taken up entrepreneurial jobs in the evenings. Some women have started their own grocery shops from their houses. They've saved money, they've bought refrigerators. They provide that service to the other houses in the same settlement. So we've seen that change and seen them grow not only in terms of how domestic electricity has provided convenience and safe living condition, but also how commercially each houses are making a little more money to save for themselves and for their children.
The Green Switch project has so far given energy access to 30 communities and over 5,000 people, but meeting the needs of all requires a different scale of ambition and resources.
It requires a huge investment, a huge effort, lots of technology intervention, finance, to actually make sure that it happens on the ground. You're talking about billions and trillions of dollars of support to developing countries, and frankly it is required because just given the scale of India, okay, it's just one country with such a huge population, and electricity is just one issue, and you cannot talk about anything else if the communities don't even have electricity and water and food. Just the basic living conditions are not met.
Adequate provision of clean energy is not a simple challenge with a single solution. We've seen how energy is involved in nearly everything we do and every technology we use, and how our energy needs and the best way of meeting them vary massively by geographic and economic context.
Of course, at the heart of this net zero journey is a commitment to sustainability. And I'm a great believer that one of the most sustainable fuels is optimism. And when I speak to my students or my colleagues or my industrial partners, having an opportunity to create the future is a real driver for participation. And if I had a very clear message for policymakers and indeed industrialists and innovators and society itself, is that it's in our will and in our control to participate and collaborate, to design, to invest in, to create and live within that new net zero future.
Join us in our next episode, Transport, to continue our series of video explainers on how to deal with climate change by harnessing a whole system transition to net zero, guided by justice and enabled by engineering. Our transport systems touch all aspects of our lives and the economy. Transport technology and infrastructure has allowed us to travel and move goods and materials with unprecedented ease all over the globe. But that mobility comes at a price. Transport is one of the biggest emitters of greenhouse gases, responsible for around 1/5 of total global emissions. And those emissions are growing faster than any other sector.
The biggest challenge with this is that over 95% of the whole transport system is still fuelled by fossil fuels. When you take a lot of developed economies around the world, the transport system is the only system of the economy which has tended not to have reduced its emissions so far. So to do the things that we need to do to get on the pathway, the trajectory that the Paris Agreement is telling us we need to be on, we've got really a decade to at least halve the transport emissions from the transport sector.
We need to act fast, but solutions must be engineered around the transport sector's most important component, the people who use it.
Transport or travelling is what's known in the jargon as a derived demand, i.e. you don't really travel for travelling's sake, you're travelling to do something, to access something, to buy something, to go to work, to visit friends and family. That makes transport, I wouldn't say uniquely, but certainly very challenging a thing to tackle and to try and change, because ultimately you're changing things which are essential to people's functioning in everyday life.
In this episode of Getting to Net Zero, we're going to look at the crucial role of people in transport systems and how that needs to shape the engineering solutions for reaching net zero. Greenhouse gas emissions from the transport sector have more than doubled since 1970. Road travel, mostly in the form of passenger vehicles like cars and buses, is responsible for 3/4 of that. The rest comes from aviation, shipping, rail and freight. In discussions about creating a net zero transport system, a great deal of focus is placed on using technology to decarbonise these vehicles.
The overwhelming emphasis is on technological solutions in transport. And in terms of passenger transport, the overwhelming emphasis is on electric vehicles. But then something that concentrates the mind If tomorrow 100% of new car buyers bought electric vehicle, and we're only up at around 10% globally maximum, but if 100% from tomorrow switched to being electric, it would still be 15 years before every single car on the road was electric, because that's how long it takes to renew the fleet. So this means a very long, slow, incremental change, which we just cannot afford to be placing so much reliance on.
At the moment, I think the mindset is there's a technology change. We change the fuel, we change the networks, I've been talking about that, and so on. That's a kind of technology change, and somehow or other by doing that you'll kind of fix it. But actually that isn't going to fix it.
Technology is a vital component of reducing transport emissions, but it is not enough on its own. The technology choices we make need to account for the dynamic nature of transport needs, and the social and economic impacts need to be considered as part of an integrated net zero strategy. So what does that look like in practice? Where transport infrastructure has built up over decades, local people and economies come to rely on them, making changing those systems complicated. It's important to recognise there is no one-size-fits-all solution. But one framework to help us think differently about reducing transport emissions is the avoid, shift, improve hierarchy. The first priority in this hierarchy is helping people avoid the need for transport altogether, when possible. That can be done with smart infrastructure and town planning that places people's needs, work, shops, education, etc., within easy reach of their homes. The next most important action to take is shift. When we can't avoid travel entirely, we need to shift from high-emission journeys to low-carbon alternatives. This might mean switching more journeys to public transport, to lower-emission vehicles, or to active transport, like walking or cycling.
So it's saying, how can I do what I need to do by walking, by cycling, so that actually when I have to use some kind of mechanised motorised transport, actually it's because I have to.
When we can't avoid or shift the high-carbon journey, we then improve. This means preventing as much of the environmental cost as we can through engineering. This can mean making modifications to engines or vehicle designs to make them more fuel efficient, which is particularly important for large planes and ships for which low-carbon alternatives are not yet available at the scale required. But it can also mean getting the most out of the existing transport infrastructure.
There's a lot of embedded infrastructure, so railways would be a very good example, very hard to move. We're not going to realign all the metro system to go around the city instead of going in and out of it, so they're probably the most environmentally sustainable thing to do is probably leave them where they are.
The Avoid, Shift, Improve framework challenges us to ask the big question first. What do we want and need from transport? Before asking, how do we all switch to electric vehicles, for example, you'd ask, what needs are we addressing with transport? How could those needs change or be changed? And having reframed the problem, what solutions and outcomes do we want to work towards? Asking bigger questions and thinking creatively about the problem can lead to transport solutions which are also socially and environmentally transformational. Medellin, the second largest city in Colombia, is located in a narrow valley of the Andes, with the poorest neighbourhoods, or barrios, situated on the steep slopes above the river. In the early 1990s, the city was experiencing a crisis of violence spilling over from conflicts within the narcotics economy.
One thing that is important to understand is that during the 80s and 90s, because the violence, you cannot go out to the street. We lose the public space, we lose the city, the urban condition of the city, and all the places start to be like enclaves, not protected, the public schools on the barrios behind fences.
At this time, the barrios communities were largely isolated from the more prosperous districts. People would travel down the slopes for work, but the journey was long, congested, expensive, and often dangerous.
So the question at that time was, how could we move forward in relation to integrate, include, and reconnect the city?
The first step the city took was to build a metro system through the base of the valley.
This gives accessibility to the main axis, but to have accessibility to the houses, to the slopes, to the neighborhoods, the city started to think in other possibilities. And that was the reason because the idea of the teleferic or the gondolas appeared.
Medellin's gondolas are a system of cable cars built around the city's initial metro system that today provide mobility and opportunity to previously isolated communities. The system is powered from Colombia's electricity grid, so mostly low-carbon hydroelectricity. It also prevented the need for some fossil fuel-powered vehicles like cars and buses, which would otherwise have emitted 70,000 tonnes of CO2 in just the first 6 years of the gondola's operation. But as well as being a sustainable design, these transport projects have helped transform the city as a key part of a wider campaign to make Medellin a cleaner, safer, more accessible city for its inhabitants.
The community was deeply involved in the process. We start to identify priorities with the community in relation with the barrios, how a mother goes from the very early in the morning, take the kids to the school and then move to the work and take the cable car station. There is a network as well of library parks that the city developed with these cable car stations and cultural centers.
Involving the communities directly in how the cable car system was designed and executed has made for a more robust and sustainable solution, and demonstrates how building a tailored transport system can be core to a wider programme of social transformation. And the transformation continues. Since the gondola's installation, Medellin's cable cars have since been joined by another innovative transport solution. Solar-powered escalators zigzagging across the hillsides now link the gondola stations to other inaccessible parts of the city, allowing even more of its inhabitants to enjoy the benefits that come with increased mobility. Medellin's problems have not evaporated overnight, but it's a very different city today to how it was 20 years ago.
It's clear for us that those programs and projects that has more sustainable conditions and has the possible to grow and to expand were those projects that from the beginning has a more robust and more inclusive participation and engagement of different partners and community.
We can only reach net zero if all the connections between technological solutions and the people and environments they interact with are understood. In this series, we've seen how buildings connect to the material world, how energy connects to economy, and how transport connects people. A systems approach to net zero is fundamentally about changing these things together, so that a separate strategy for one system, like energy or housing, doesn't constrain the transition of others, like transport. It's a simple idea, but as we've seen, this broad and inclusive approach can produce exciting results, allowing us to find the best engineering solutions to support lasting system change on the journey to net zero. Join us next time as we get deeper into what else is needed from policy, people, and engineering to get to net zero. In February 2022, the Intergovernmental Panel on Climate Change published their 6th assessment report. Its verdict is dire. Climate change has already caused substantial damages and irreversible losses across all ecosystems and contributed to humanitarian crises around the world. Around 3.5 billion people, nearly half the world population, live in contexts that are vulnerable to climate change. This will increasingly put pressure on food production and access, and significantly increase ill health and premature deaths from the near to long term. The report found that it is already too late to avoid or reverse some of the impacts of climate change. As a result, reducing the severity of future humanitarian disasters requires us both to reduce and mitigate our greenhouse gas emissions, whilst also adapting to be more resilient.
you don't know how helpful a stable climate is until you don't have it anymore. I remember one politician saying to me, it's a bit like running water or electricity. We're so used to living with those things that we can't imagine what it would be like to live without them.
So far in this series, we have looked at the challenges of transforming our systems of energy, transport, and the built environment to cut carbon emissions to net zero. But as the effects of climate change are felt around the world, we need to add a new requirement: adaptation. Integrating all of the challenges we face into one transformative strategy is not easy, but we've already seen how systems thinking can help us do that.
Systems thinking, I see it as a way to grapple with the world as it is, which is complex and interconnected. And systems thinking offers a way to work with that complexity and with that interconnection instead of fighting against it. And so in the context of reaching goals like net zero, those aren't incremental goals, right? Those are goals that we're going to have to leap towards faster than any energy transition in human history. The danger of not using a systems thinking approach to tackle net zero is creating unanticipated problems or creating short-term solutions, but with long-term consequences that future generations will have to pay the price for. So, not only does systems thinking give us exactly the tools we need for transformation, but it also is sort of a safety guard against some of the worst failure modes.
In this final episode, we'll look at a resilient transition to infrastructure, economy, and lifestyles, which are not only net zero, but also protect against extreme weather events and environments. And get to know two system approach tools that are vital for developing an integrated climate strategy. This is Kibera, one of Africa's largest and most densely populated informal settlements, in Nairobi, the capital of Kenya. Here, sustainability is less a question of emissions reduction, though replacing dangerous kerosene fuels is a part of it. Kibera's challenge is instead the results of climate change. Over 50% of the community's households flooded in 2015, with rainfall rates projected to increase by up to 1/3 due to climate change.
The density and demand for space has driven development right up to the water's edge. And after any rainfall, this type of activity, of course, causes flooding, which is not helped by the fact that waste removal is almost non-existent. And therefore drains tend to get blocked with solid waste, which also means that the environment can also be extremely polluted, contaminated waters, and the grounds equally contaminated as well.
With climate change being so directly linked to well-being and economic priorities, how do they approach a resilient transition? A group of engineers and architects from the Kunkui Design Institute are working with residents to answer that question.
KDI, I think, beyond being students in university who were studying various disciplines around engineering, design, architecture, etc., were quite keen on using their skills, not just to make nice and fancy buildings or places, but to actually cause change and to also create equity and to advance social justice.
The purpose of the project is to construct public spaces which provide environmental and economic benefits for over 125,000 residents.
Most of the sites are located along the river. It allows for us to do climate-adapted infrastructure and also create community awareness while providing safe water, sanitation, playgrounds and services typically only found in formal parts of Nairobi. This has dramatically improved climate resilience for around 8,000 households, especially the low-income and single-mother families that tend to live in the cheapest housing by the river and whose children also play on the banks. So I think those are some of the important things that we've put in place.
The project owes its success to the bottom-up approach it takes to co-designing solutions with the local communities it serves. To do so, they partner with at least one community-based organisation for each of its sites.
The site, at the end of the day, belongs to the community. They feel that it is an investment they've made. They then tend to protect it where they see it is at risk, and they're also more likely to maintain it and even improve on it and let it grow further. We don't want to create a system of dependency. We want this to be community-led, community-owned, community-run, a community asset, because it starts with people and it's built on the principles of participation, integration, and network change. It is a way of modeling how people-focused design and engineering can lead to productive public spaces that enhance communities' socioeconomic status, provide for their holistic well-being, that there are no shortcuts. Because when you start engaging the community from getting their ideas and prioritizing the ideas, the process can actually take a very long time. We feel that it's an important thing to do, and it's an important way of doing infrastructure upgrading.
When it comes to engineering solutions to climate change, local context is everything. But understanding success stories like the ones we've seen in this series offers us methods and ideas that can be tailored to any net zero challenge. First, a reminder. Why do we need new ways of tackling climate change? In a net zero world, our systems of energy, transport and buildings will be fundamentally different from what we know today. The transition will require changes in the human habits and economic structures that create our demands for energy and resources. In previous episodes, we saw how infrastructure systems are so highly connected and interdependent that none of them can transform without the others. That makes it difficult to answer even simple questions about net zero technology until we understand the bigger net zero strategy.
You need to make sure that your strategy covers all the important sectors, transport, industry, housing and so on. And you need to be really clear what emissions reductions you're trying to get out of each sector over what timescale, and make sure that individual government departments and industrial sectors know the part that they have to play.
But how do we get to that strategy? And how do we make it work? This is where our two tools, called deliberative democracy and multi-solving, can help us embed the systems approach we need. Let's go deeper into each, starting with deliberative democracy. To achieve an integrated strategy for reaching a resilient net zero, and to bring the best engineering contribution to the transition, it's vital to understand the net zero lives people want. But understanding the challenges, the solutions, and the trade-offs for a city or a nation is very complicated, and political processes struggle to engage with citizens about such a long-term future. That's where deliberative democracy comes in, as a way of laying out the specific local risks, resources, and potential solutions for people, and allowing them to reach informed and integrated decisions.
Just before COVID struck, I had this amazing opportunity to be part of Climate Assembly UK. We brought together just over 100 people who were statistically representative of the UK as a whole. We spent 4 weekends working with those people, giving them access to really good information and experts, letting them talk to each other, bring forward their own experience. And we asked them what the UK should do about climate change, how it should achieve that net zero target.
This deliberative process provides feasible strategies negotiated across diverse needs, beliefs, and visions for a net zero world, which is invaluable guidance for policymakers tackling the same challenge. But more importantly, it sets the parameters for the whole transition to net zero by developing a shared vision of a good, sustainable world. But taking advantage of all the opportunities of net zero requires a change in thinking as well. We've seen why a systems approach is necessary to avoid creating unexpected problems. Without a systems approach, we will also miss out on the best opportunities and co-benefits that are all possible in a net zero future.
In 2018, the World Health Organization published this really important study. They said the costs of being on track to net zero are actually outweighed by the health benefits alone. And that's before you even think about new jobs created or the biodiversity benefits of protecting the climate. Fewer hospitalizations from respiratory disease. Economically, businesses might experience more productivity. Their workers are going to be healthier and missing work less. The costs of that transformation will largely be felt by, say, the energy minister and the transportation minister. The benefits in that country, though, will show up in other places. The energy minister, the transportation minister, their budgets show a big outlay. What do they have to show as benefits for it? You need to be able to, in some way, convene the whole system and measure the benefits across the whole to seize the kind of opportunities that the World Health Organization is talking about.
But how do we find policies that will help capture those co-benefits? That's where multi-solving comes in.
Multi-solving is a simple idea. It just means making sure that every investment of time, money, energy, effort that we put in is being directed to solve multiple problems at the same time. One example might be investing to make a city more bikeable and more walkable. It will reduce air pollution. It gives people more access to safe physical activity. Other studies have shown it's actually an economic development opportunity. As people move through a neighborhood or through the city at the speed of their own 2 feet or the speed of a bicycle, they're more likely to stop in a shop, and that's going to help local small businesses.
Multi-solving is a simple concept, but there are many barriers to putting it into practice.
One of the most obvious barriers is silos. We've created our systems in ways that have all kinds of barriers between different parts. Sometimes those are jurisdictions. They might be academic disciplines where experts speak different languages, barriers between community organizations and government officials, or between technical experts and community organizations. So all those things get in the way of people implementing these shared solutions.
Getting to an integrated systems approach to net zero may seem like a difficult task, even more difficult when accounting for adaptation as well. But with deliberative democracy, we can set a clear direction of travel towards a net zero which works for everyone, removing some uncertainty about the appropriate solutions in the right scale, tailored to local needs. And with multi-solving, we can orient our net zero strategy around achieving the best health, economy and well-being co-benefits from our climate policies. Behaviour change, technology change and economic change are each crucial for the global transition to a resilient net zero. We often see these as separate challenges, but they're not. They're tangled together in systems of human demand, technological services and economic models, which have to be reshaped to work together differently. Interconnected problems require interconnected solutions, and a change in how we go about making decisions. For engineering and technology to play their crucial roles in innovation, reconstruction, recycling and ecosystem restoration, they have to be part of a broader transition to a resilient net zero, led by a clear vision of how we want to live differently. Systems thinking lets us navigate this change. With integrated strategies, multi-solving, deliberation, and tailored local solutions, we can take control of the transition to net zero and do our best to safeguard the world.